All right, lesson 6.1, classifying polygons. You have a polygon is any closed two-dimensional figure that is made entirely of line segments that intersect at their endpoints. So polygons can have any number of sides and angles, but the sides can never be curved. The segments are called the sides of the polygon, and the points where the segments intersect are called vertices. Easiest way to identify a polygon is to look for a closed figure with no curved sides. So that's going to be huge on these next couple questions. Polygons can either be convex or concave. Think of the term concave as referring to a cave or caving in. So concave polygon has a section that points inward. So this would be a concave, 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 any section that points inward toward the middle of the shape. And then convex is obviously the opposite of that, where all of the edges point, or all of the vertices point outward. And then these would be all convex polygons. All right, so diagonals are line segments that connect the vertices of the convex polygon that are not sides. So each of these red lines are diagonals. A polygon is convex if all diagonals remain inside the polygon. So if you take a line from F to H and this line is outside, that makes it a concave. Some examples of convex polygons. So we have triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, dodecagon, and then n-gon. So if you look, you'll notice that the number of diagonals in a triangle, remember diagonal has to be from one vertice to the other. That's not a side. So from here to here, that makes a side. From here to here, there's 1, 2, 3, 4, and so on. And that gives you that. All right, so which of these figures below is a polygon? Remember, it has to be a closed shape without any curves. So we have a curve, we have a curve, and we have an open shape. So this would be polygon A. All right, same thing here. Which of the figures below is not a polygon? Each of these are two-dimensional figures. Figure C is three-dimensional. That is not a polygon. And then which of these figures below is a polygon? This is not a closed figure here, not closed. This one has a curve, so figure D. All right, so then determining if they are concave versus convex. This has one vertice pointed inward, so this is concave. All of these point outward, so this is convex. Classifying, we're going to classify as concave or convex as well as number of sides. So there's a couple that you can practice on. So this one, each of these point outward. So this is convex, and then we'll count the number of sides. I'm going to start at the top here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is a decagon. These three vertices point inward, so that is concave. And I have 1, 2, 3, 4, 5, 6 sides is a hexagon. There's some extra practice. So we have irregular versus regular. So a regular polygon has congruent angles and congruent sides. So any polygon can be a regular polygon. Look at these examples below. If it does not have congruent angles and congruent sides, it is considered an irregular polygon. So there's a couple of examples that you can practice with. And so this would be, not all of them are the same. So this is irregular. And then I'm going to start here. So 1, 2, 3, 4, 5, 6, 7 is a heptagon. These are all the same. So this is regular, 1, 2, 3, 4, 5. 5 is a pentagon. And then, so interior angles of a polygon are ones on the inside of the shape. A polygon has the same number of interior angles as it does sides. So a quadrilateral has 4 interior angles, a pentagon has 5 interior angles, and a decagon has 10 interior angles. So we have this formula here. Polygon sum formula states that for any number n, so n being number of sides, the interior angles add up to this n minus 2 times 180. So this is going to be a formula that you're going to want to write down. So for example, this polygon has 8 sides. It's an octagon, so n is 8. If we do 8 minus 2, we get 6. 6 times 180 is 1080. Couple more examples. There is a video for you to watch as well. Once you know the sum of interior angles of a polygon, it's easy to find the measure of one interior angle of that polygon. You'll just divide the sum of the angles by the number of sides. So there's another example for you to look at. So here we've got 6 sides. 6 minus 2 times 180 is 4. 4 times 180 is 720. If I wanted to find the measure of one angle, I would take that 720, divide by the number of sides, which is 6. So the measure of each angle, each interior, is 120. So for this one, find the sum of interior angles for each polygon. So this is 4, 1, 2, 3, 4. So I'm going to take 4 minus 2, and times 180. That'll give me 360. And this has 1, 2, 3, 4, 5, 6, 7, 8 sides. So I'm going to replace this number with 8, and that gives me 1080. For this one, find the measure of each interior angle. So 1, 2, 3, 4, 5. This has 5 sides. So I'm going to replace this. And then to find the measure of 1, we're going to take 540, that total from above, divide by 5. Gives me 108. And then this one, 1, 2, 3, 4, 5, 6. So I'm going to replace this with a 6, 720. So 720 will be the top of my fraction. And divide by 6 sides, gives me 120 each. All right, so then the exterior angle is an angle that is formed by extending a side of the polygon. Added all together, the exterior angle sum theorem states that the sum of exterior angles of any convex polygon is 360 degrees. So the sum of all the exterior angles here is 360. To find the measure of 1, you would then, again, divide by the number of sides. So 360 divided by n, this has 10 sides, giving us each exterior angle measures 36. For this one, 1, 2, 3, 4, 5, 6. Again, we start with 360. For any polygon, the sum of exterior angles is always going to be 360 regardless of the number of sides. So we'll start with 360 divided by 6. That gives us each exterior angle measures 60. So find the measure of one exterior angle in each regular polygon. We're going to take 1, 2, 3, 4, 5. This has 5 sides. We're going to start with 360 and divide by the number of sides, 5. So this is 72. And this has 1, 2, 3, 4, 5, 6, 7, 8. So 360 divided by 8 is 45. and a couple other examples for you to look at, real world connections. Make sure to go through those. And that's it for that one.